Bobo. I'm Jim Fulton. I'm the CTO at Zope Corporation. I led the Zope project for many years. We actually don't use Zope at Zope Corporation anymore, but anyway. But I've been involved in Python for a long time. I realized this year that this is my 20th year using Python. And anyway, so I'm going to talk about a project that I developed a few years ago and has worked out really well for Zope Corporation, so I wanted to share it with some more people. I like questions. It's a pretty small group, so feel free to interrupt me. I like to answer questions when you have them. So I'm gonna talk about why I created Bobo. I mean, there's a bazillion web frameworks out there. Talk about the basics. And some more slightly less basic things, and then how many people here are familiar with whiskey? Okay, so not that many. I think so. I assume everybody here is somewhat interested in web. So whiskey is a good thing to know about. So I'll talk about that a little bit. Depending on the time, I may talk a little bit about history. I also may show a little bit more in-depth example. So. How many people have heard of Zope? Okay, well, it's not as infamous as it used to be, but Zope has a complicated history, but it was a big, it's a big application that is sort of extensible and has a bunch of frameworks in it that try really hard to help you, but in the end, sometimes can require a big investment. I had a conversation several years ago with Bruce Eckel, who was a Zope user and at the time, and he mentioned to me that he only had to modify his site every few months, and every few months he had to relearn Zope. So I wanted to come up with a solution that people wouldn't have to relearn, or if they did have to relearn it, they could relearn it in a few minutes, so that there wouldn't really be a sort of a problem not using it for a long time. Also, Bobo seeks to provide as natural a programming experience as possible. So it tries to sort of view the web as kind of a remote procedure call mechanism. So your server is providing data to apps, especially in this day and age, depending on what you're doing. Its goal is to provide a very low commitment. Again, easy to learn, but also easy to relearn, and not intrusive in the rest of your application, and a lot of sort of low coupling. And fairly explicit but easy configuration. The only thing Bobo really does is publishing objects. So its goal is to just make your objects available on the web. It doesn't do database integration. It doesn't do templates. It doesn't call Celery. It's just really about publishing, with the point of view that all those things are easy to do. And Bobo's philosophy and opinion is your web framework doesn't really have to be involved in that. So frameworks like Bobo are called micro frameworks because they're very small. Some micro frameworks sort of take the approach that, well, they're good for small problems, or you can extend them. But Bobo's attitude is that really publishing objects on the web really has very little to do with lots of other things. There are lots of other, interesting web activities, like templating if you have to do that, or form handling, but the basic publishing process can be orthogonal to that. So low coupling isn't really meant, the micro in a micro framework doesn't really have to mean it's for micro problems. It just means that, or it could just mean that it wants to sort of separate concerns. So I've been doing this a long time. I've been involved in designing frameworks for a long time, and there are a lot of challenges. One of the things that I've noticed is that people often rush to abstractions too soon, or they embrace abstractions that may not really provide value that outweighs their costs. Abstractions aren't free. They make software, they often make software harder to understand because you have to sort of understand the abstraction in addition to the code that's using it. They often impose architectural choices. So for example, some abstractions require registries or component systems, or that you lay out your software in a particular way. They often lead to boilerplate code. And they can increase the learning burden. Now, of course, abstraction is a wonderful tool if the abstraction really pays for itself. And really, to pay for itself, it has to provide benefits, in my opinion, that are significantly better than the costs. And what I've noticed is too often the costs aren't fully appreciated. Also, what I've noticed is that when a framework provides lots of abstractions, the cost of any individual abstraction can be very low, but the overall load of all the individual abstractions can end up being pretty high. Abstractions sort of remind me of a scene in Jurassic Park 2 where one of the characters is talking about it, how it always starts out with everybody really, thinking the dinosaurs are really cool, and then after a little while they're running around being eaten by the dinosaurs. And that's kind of how I see abstractions sometimes. Another thing I've noted is that a lot of times simple abstractions, especially abstractions to provide syntactic sugar, are often best applied locally based on local needs. So I think it's a good idea often to add application-specific abstractions. And third-party abstractions might be great, but they might not fit your application very well. So again, if they do something really valuable, then it doesn't really matter. It's worth the cost. So anyway, Bobo uses routes, and lots of frameworks do these days, so this should be pretty familiar. Basically, when you want to provide a function that's accessible via the web, you mark it with a decorator. In this case, we're marking the hello function as accessible at /. Pretty trivial. Bobo comes with a little development server, and so if you install Bobo, you can just point it at a Python file and get started. And I actually quite often start projects this way. I might start just sort of goofing around, experimenting with different ideas this way, and I find it very useful. So it comes with a little development server. It allows you to just point at a source file without setting up paths and without setting up setup pi or anything like that. It auto reloads the source file for you, so you don't really have to keep restarting the server. It provides optional post-mortem debugging, so if you start it with a certain option, it'll drop into PDB when there's an error. And it's got some built-in support for serving static resources, which is really helpful if you have resources like JavaScript files that you need to use along with your application. Installation is suitably boring. You can install it with pip in the usual way. I happen to use build-out a lot, so I often install it with build-out with a command like that. And Bobo is a single file, so you can copy it into your path. And this is useful in situations like running in Google App Engine, where the way that you package things is a little bit different. So it makes it convenient for situations where pip or build-out aren't really quite applicable. So again, it uses routes like many server and client-side frameworks do. It should be pretty familiar for the most part. It does have some slight innovations that we'll get to later. So you have a route that either may have constant parts like this handles URLs that start with greeters, and then you can have variable placeholders. And so when your route handler is called, then an argument will be passed corresponding to the placeholder. The placeholders can be optional. I don't really use that much. And then, as we'll look at later, the route system can handle recursive data structures. So some people talk about traversal as a way of sort of traversing an arbitrary data structure, and the route mechanism can handle that without much effort. So when you write a route handler, you can return, most route handlers simply return a string. Might be a result of, well, it kind of depends on how you're approaching it. If you're having a route that returns HTML, it's very common to just return a string, and Bobo will turn it into a proper response. Bobo uses something called webbob, which I'll talk about more in a few minutes, but you can return a webbob response. If the content type of the route is application JSON, you can return anything that can be serialized to JSON, and you can also control the content type in general. In addition to getting arguments from route variables, you can also get them from form variables or JSON bodies. And this gets back to this concept of sort of natural Python, where you can write functions that take arguments that are called from the web, but you can sort of write them as if they're called from other Python functions. And in fact, if we get a chance to look at some example code, quite often you can actually call one route from another route, because Bobo goes out of its way to make sure that anything that's decorated with a route handler can still be called as if it was undecorated. So anyway, this is all pretty simple and boring, but that's part of Bobo's goal. So again, natural object call. So the current Bobo release is a reboot of an earlier version of Bobo, and the earlier version of Bobo from, again, about 20 years ago, not quite, was sort of a science project geared towards, can we publish objects on the web with little or no changes? Can we sort of treat the web as an object system where you make a HTTP request and it calls into an object? And that's still sort of the spirit of Bobo. And so, again, we want to be able to call something in as natural a way as we possibly can. One thing that makes that kind of inconvenient, and the old Bobo had some sort of awkward things to try to get around this, is that if you've got form data, all the data are basically strings, which is okay. I mean, it means that your handler has to do conversions, but it's a little inconvenient, and it sort of breaks the illusion of being called from Python. You can use JSON bodies, and if you call your route, if you make a web request with the JSON body, then the parameters can be marshaled from that JSON body, and that gives you the advantage of having some data types beyond just strings. You can actually have strings and numbers and mapping objects and lists. So. And nested structure. So you actually now, with JSON, have much richer data, but it still might not match your Python data. I mean, a good example is date-time values. A future version of Bobo will leverage Python's new optional type annotations, so that if you have optional type annotations, then not only will the inputs be sort of checked against them, but they can be used as conversion functions. So for example, if you have some sort of date representation in JSON, you can have a handler that recognizes that representation and not only checks it, but also gives you back a Python date time or whatever you want. So I think that'll be kind of cool, at least once we can all use Python 3. We tried to use Python 3 in our latest project, but it was still the case that too few of our dependencies were ported. But anyway, the philosophy is that when the web calls you, you're being called in much the same way that you would be called from Python, and that makes this kind of development a lot more pleasant, in my opinion. So Bobo uses webbob. There was an effort a few years ago to try to come up with a standard way of representing request data, and that was webbob. And so a number of frameworks adopted it, and so I did as well. App Engine supports it, so it's really easy to use Bobo with App Engine. And Bobo is also whiskey-centric. I'll go into whiskey in a little bit more in a few minutes, but at a high level, WSGI is a mechanism for combining a bunch of different high-level components together to try to make development easier, rather than having a large framework that's well, maybe interdependent. Maybe there are certainly other options as far as component systems for Python, but WSGI was an attempt to have at least a component system for the web, and it's been pretty successful in that regard. But I'll say more about that in a bit. So Bobo provides a number of types of handlers. The most commonly used are the sort of RESTian handlers, corresponding to the sort of common HTTP request methods. There are some other handlers that are used wildly less often. There's a resource handler that allows you to have a single handler that can handle multiple request methods if that's something that you want to do. I generally like to have my software be simpler, so I prefer to have separate handlers for separate methods. And then there's this query handler that handles both get and post for sort of historical reasons, and probably shouldn't be used. I probably shouldn't even have mentioned it, but okay, so you now know 62% of what you need to know to use Bobo. And to use it in a pretty scalable fashion in the sense of complexity. We've developed quite a few applications with it, and you really don't need to know much more about what I've talked about. The next sort of level is subroutes. And a subroute, the idea of a subroute is to split the handling of a particular URL into multiple steps. And there are sort of two main reasons for that. One is to provide some abstraction in your handlers. For example, if you're dealing with database data, you might want to centralize some of that database handling, or you might want to centralize fetching information about a user, or have things that apply to all routes centralized in a single place. And so you can use this mechanism for that, but it also provides just a way of kind of separating the URL space so you can have it less monolithic, and you can handle recursive data structures. So here's a fairly simple example. It's the data's all contrived because we want to try to keep it really simple for the example, but imagine we have a database. In this case, this database is a list. The indexes are indexes like 0 and 1. And so I should mention that the most common way to use a subroute is with a class. And so when we do that, we say Bobo subroute and give a URL prefix. And we usually, if it's with a class, we usually say scan equal true. And what the scan does is it tells Bobo to look through the class for handlers, so it knows how to actually call individual methods within the class. And so in this case, we have a class, and it has route handlers, just like we saw before, but these route handlers will be called after the route given in the subroute is going to be called. So all three of these handlers will be called for URLs that begin with employee/employee ID. And the constructor, well, it squirrels away the request because that's convenient. You often want to have the request, and it also saves the employee ID so we can use it later. And then we have some sort of trivial route handlers. Okay. If you don't let me lose you, so if you're if you're confused, stop me. So now let's look at a slightly more complicated example, and this is going to be as complicated as it gets in this talk, pretty much. Imagine that employees have documents, and we want to make those documents. They've got documents that they want to share, and the documents are arranged into directories. And again, we're going to, for the sake of the example, be really silly and represent the document trees as dictionaries. Of course, you wouldn't do this in reality, but it's just to make the example simpler. So now we've modified our database so that the items in the database have more data in them. Again, it's just an example. So we now have only one item in our database, and the item is an employee whose name is Bob. And they have a documents attribute, which you can see is either a value of a string or a value of another dictionary, sort of representing a directory. And so we want to be able to, with URLs, reach into this regardless of what the data are, regardless of how deeply they might be nested. And a lot of routing systems don't do this very well. But so the way we're going to do that is we have our class, and I've elided the stuff that you've already seen. And now we have another subroute, but this time we're not using it with a class. We're just using it with a function. And so here the function basically returns a new, basically a new collection of handlers. And so it's going to return an instance of a folder class. And we'll see the folder class on the next screen, but the folder class is itself going to, the folder class is only a subroute by virtue of it being called here. It won't have a Bobo subroute decorator on it. So our folder class, it uses Bobo scan class, which is similar to that option that we saw in the subroute, which basically tells Bobo to look through the class for handlers. It has, a common pattern is to have a route handler for the empty string that simply redirects to slash. This is kind of like what a lot of web servers do. The most important one is this one, which is yet another subroute, and this says if I get an item, and that item, so if I get an item, I'm going to, well, let me back up. I start by passing in some data. Let's look on that last screen again. So when I created a folder, I passed in the documents item from the employee record. So I got the employee record, I got the documents out of it, and then I said, okay, here folder, here's your data. If we were going against a file system, this would probably be a path instead. But again, just to make the example a little bit easier, we're just passing in dictionary data. And so then when we traverse that folder with a name, basically, we have our data, which was the documents collection, and we look in the data and we see, and I'm skipping the key or case. We look in the data and we see is it a dictionary or a string. And if it's a dictionary, we create yet another folder, and of course this time we initialize the folder with the data that we just got. And so as you can imagine, the whole process sort of starts over at that point. And if it's not a folder, then I return a document, and the document is very simple. It simply has a get method, a get handler that returns the content of the document. So with this, you could you could serve content from a file system, you could serve content from a hierarchical database. And it really wouldn't matter how deeply nested the database or the file system was. You could handle sort of any kind of nesting. Any questions so far? So the last bit that people commonly deal with in Bobo are checkers. And checkers are functions that you can supply when you define the route that get called, if present, they get called before the route handler is called. And if they return a response, then that response is used instead of the route handler. And the most common use of this is to handle authorization. And possibly to demand authentication. So this is a really simple example. Imagine that this is an app that simply requires that the user has been authenticated somehow. We'll talk about how they might be authenticated in a few minutes, but just imagine that somehow they've been authenticated. If we're sitting behind something like Apache, we might have Apache have done the authentication, and the request has a remote user, which is sort of a standard request attribute that says some sort of identifier for the remote user. In this example, all we're saying is, well, anybody who's authenticated can use this, and if they're not authenticated, then we return a response with the status of 401, which is typically used to challenge a client for authentication. If we were doing authorization, and if we have time to look at an example, I'll have a trivial example of that, then you might return a 403 for forbidden to indicate, well, you're authenticated, but you're not allowed. So, for example, you might require that only authenticated users can update the database. Okay, so now you know, except for some really sort of obscure edge cases, you know pretty much everything you need to know to work with Bobo. So, I'd like to talk a little bit about Whiskey. I think it's, regardless of whether you use Bobo or not, as if you're doing web development with Python, it's good to know about Whiskey or WSGI. The basic idea is that an application, a web server application consists of a layer of components. At one end, the way I think of the top end well, I guess it depends. Yeah, so one end are servers, so requests come into servers, and then they go down through 0 or more layers of middleware, and then they talk to your application. So before this existed, every web framework had a different way of connecting to servers. Some web frameworks actually embedded a server as part of the framework because there was no standard way to hook servers up with frameworks, or there were various techniques, but they were cumbersome. So Whiskey provided a standard interface for connecting servers and applications, and this really was a great boon to Python, the Python web world. And then as a bonus, there was this concept of middleware, which provides a way for components to add value where those components are really unrelated to the rest of the components. So to look at an example of that, when you run the Bobo development server, it's actually creating a very small, well, not very small, a small Whiskey stack with the Whiskey Ref Simple server, which is a built-in sort of toy web server that's included in the standard library, together with a middleware component called debug, which is responsible for dropping you into the postmortem debugger on an error if you request it, and the Bobo server reload middleware, which takes care of reloading modules, and then your application, where your application is basically an instance of Bobo application that wraps all your handlers and takes care of calling them. This concept is actually really powerful. It allows a lot of nice tools, not only sort of routine tools like middleware for doing authentication, for example, or doing caching, or knitting multiple applications together, but it also provides the opportunity for some nice development tools. Here's a slightly more complex example. This is the project that I'm currently working on. It's primarily a mobile application. We're using Bobo. The server in this case is not serving primarily web clients. It's primarily serving Android and iOS clients. And the Android and iOS clients are making calls to the server, sending and receiving mostly JSON data, except when they have to send an image. And so anyway, we have a bunch of components here. Here's our application at the bottom. We use paste URL map to actually map different domains to different parts of our application. ZCDB connection is misspelled, which is good because I don't like it, but it has to do with some sort of an interesting details of making database connections available within the app. Translogger is a little component that takes care of creating access logs for you. ZODB Whiskey is a middleware component that takes care of setting up a ZODB database. I'm a big fan of ZODB, but it could be any database. Repose Retry is middleware that takes care of retrying requests if there's a conflict. Many databases have a concept of conflicts, typically conflicting writes. And so in a situation like that, you want to automate retrying requests if you get a write conflict. And so Repose Retry does that. Paste Error Catcher is a middleware that catches Python exceptions and turns them into 500s. This is annoyingly valuable. In order for Repose Retry to retry requests, it has to recognize that there was an error. And so typically the way that's done is you let errors percolate up to Repose Retry so that it can detect conflict errors and retry. But then you need something to actually generate 500s. Bobo normally does that, but in a case like this, you want to have Bobo not do that and so that the errors can be handled by middleware. There's a lint checker that we only use in development, and finally we're using Zope Server, which is it's one of the many Python web servers. We use it because it provides sort of how many people are here familiar with New Relic? Well, so this provides like poor man's New Relic. It provides some basic trace logging so that you can look at the performance of your application in real time. But anyway, so one of the coolest Whiskey components is WebTest. Has anybody used WebTest? Oh, it's very nice. It basically acts like a Whiskey server, and so you can in tests you can ask it to make requests of your Whiskey stack, and it'll make the requests and then show you the results. And so this makes it really easy to test your web handlers without using a browser. It even has some minimal capability for doing some of the things that you might do in Selenium, like clicking, like selecting form elements or filling in form elements. But it's especially nice when dealing with things like AJAX calls where you're sending data back and forth, because you can sort of introspect and test the values of the data. So when you're ready to deploy your app, a tool that we use and that I sort of recommend on some level is paste deployment. And what it does is it basically gives you a high-level way of knitting different components together. It leverages a feature of setup tools to let you give components names without requiring clients to know exactly how to import them. And so it provides a little framework for knitting components together, and both APIs for leveraging the framework from Python, as well as a little tool that handles the config file for you. If you're into that, which we are to some degree, although we push some of this down to Python using some of the paste deployment APIs. And then when you run Whiskey stacks, there's a tool that came with paste deployment. Well, it didn't quite come with it, but anyway, there was a tool that sort of was included with paste called paste script. It was sort of okay. It was missing some things, but not enough for me to care until we decided to try to port some of our stuff to Python 3, and it hadn't been ported. And it's also just it mixes a whole bunch of things together in strange ways. So a few months ago, I wrote ZC Whiskey Runner. It works with Python 2 and Python 3, and it also provides process level configuration, which paste deployment or paste script didn't, or paste deployment in general didn't really let you do. It can be used for any Whiskey app. It doesn't have to be Bobo, of course, but I think it's a better alternative to paste script. Especially, it's the only alternative, I think, still, if you want to do Python 3. And then I generally recommend you can if you're running on a Unix-based system like Linux or or Mac OS, typically when you have a long-running process like a web server, it needs to be demonized. It needs to be set up to behave properly as a long-running process. Getting that right is really hard. Life is short. Don't pick hard things to do. Use another demonizer. And there are many choices in the Python world too that sort of stand out are ZDaemon and Supervisor D. ZDaemon, I like it a lot. Just because it's really simple, not very powerful. And what it does is it runs as a daemon and then controls an arbitrary program to do things like start, stop, restart, run in foreground. And it's just battle tested and very simple, and it works reliably. I've taken applications like various non-Python daemons that did a crappy job of demonizing themselves, and I fixed them by just wrapping them with ZDaemon. Supervisor D is sort of ZDaemon on steroids, and it can manage multiple processes, and it's kind of annoying to have a separate ZDaemon process for each of your processes, but that's part of the price you pay for simplicity. And then, of course, depending on the situation, you might have other ways that you sort of need to wire things up. But anyway, so getting back to Bobo, you might be wondering, well, gee, what about templates or database connections? And you may not buy this argument, but I think it's a pretty good argument that all those things can be done without mixing them up with your web framework. So, for example, if you want to use Jinja, it's pretty easy to do some setup, and then in your handler, simply call a Jinja template. Some frameworks provide some syntactic sugar so that you don't have to do this, but then you have to know what's happening under the hood. And if you want syntactic sugar, it's easy to get similar sugar. If you want to sort of not have to explicitly return, call a template, you can certainly arrange that if it really bugs you using an application-specific bit of sugar. But if you're using third-party sugar, now you're really dependent on some decisions that might have been guided by factors that really aren't important to you. Even Zope, which has been sort of criticized over the years for being too monolithic, its attitude was that a template is just another callable, and it's better to do stuff like that explicitly. Databases are a little bit more complicated because you don't really want to have to do database setup in each individual route handler. You want to centralize that somehow. There are a lot of ways you can do it, but one way that we've done is to do that in Whiskey middleware. And so the basic way that works is you have some middleware that for each, so you have some Whiskey middleware that when you initialize it, sets up a database, some sort of database configuration. A lot of databases have a concept of a database that you then open connections to. And then when you get a request, you then open a connection for that request, and you make that connection available as part of the request environment. So when you use ZCZODB Whiskey, then inside the requests have an environ attribute, which is basically a dictionary, and you can look up the database connection there and get it and then use it. So anyway, it's pretty straightforward. There's really, in my opinion, there isn't a really huge win in sort of making your database access part of your web framework. You can certainly have frameworks that automate the database access, even generating HTML from databases, but that still doesn't have to be tied up with your publishing environment, in my opinion. So. Before we talk about history, if we talk about history, I'd like to show you a little bit more interesting example. If I can, let's see. It's not that one. It is, where was that? Oh, it's up here. So, is that text large enough for you all to see? So the first thing I'm going to show you is an example of using WebTest. I'm a huge fan of DocTest. There are reasons why people dislike DocTest, that's fine, but I'm still a huge fan of DocTest, so this is an example of DocTest. You can certainly use WebTest without DocTest. So the first thing I'm going to do is I'm going to import my model, and in my test setup, which I won't go into all the details of, one of the nice things about using ZODB is you can say, give me an in-memory database, and that makes it really nice for testing because you can just sort of very, very cheaply set up a database for each test. So anyway, we're opening up a database connection. This is an application maybe a year ago, I wrote a two-tier Kanban application. I'm a fan of Kanban. Anybody know what Kanban is about? The details aren't really that important, but it's basically a graphical application where you have software projects. You have a Kanban, basically it's nested Kanban boards, and so you have a higher level Kanban board that has your projects as if they're individual Kanban tags, and then when a tag goes into development, it explodes into a nested Kanban that has the individual stages, and that allows you to sort of marry some of the benefits of Scrum and Kanban together. Anyway, when I first implemented this, I implemented it on top of Asana, and Asana has become really slow. So I'm in the process of rewriting it to be on top of a database, in this case ZODB. So anyway, we have a Kanban object that represents one of these Kanban boards, and so the first thing we do in our test is we add it to our database. I have this test app function which basically just calls WebTest with my Bobo application, and it provides a little bit of sugar for doing that. It also accepts an email to sort of act as remote user, so I can test the behavior of authenticated and unauthenticated. And then I can call web methods on it with URLs and data and verify the results. In this case, you can't access anything in the Kanban unless you're authenticated. So for example, if we try to download the model that the client needs in order to sort of display everything correctly, we get a 401. So when you call a WebTest function, you pass a status code of what you expect. The default, of course, is 200. And if you don't get that status, you'll get an error. So, and then I start making some calls. So first thing is I create another test application that has this email as the remote user. And if you look up here, when we initialize the Kanban board, we specified the initial admin user. And so now this allows us to actually make requests. So this fetches a JSON representation of the Kanban model, and the details aren't really that important. I just want you to sort of get a feel for how some of these tools make testing easier. Here we have. When dealing with JSON, I like to. Here we've actually turned things around a little bit. The reason is that this application, we've been working on a model for synchronizing clients and servers. We've been using this in our mobile apps, and the basic idea is that there's a sort of image that is generational. And so when a client contacts a server, it supplies a generation number of what generation of the data it's seen. And in addition to any responses that the server might provide, it also provides updates for the client's data. So it provides a really nice, clean model for keeping the client's view of the data and the server's view of the data in sync. And so every time we make a request, the server sends an update, and in that update is the new generation. And so we have to update the client state, and so there's a little helper function that does that. So you'll see a bunch of these requests where the output is really just the updates to the data model, but it also allows us to see the sort of effect that we expected from the call. So here, for example, we call the poll route, whose sole job is to return any updates. And so now we send back update data. And this just sort of goes on like that. This project is available, is a public project available in the ZC Bitbucket account if you're curious. And so I won't bore you with more examples other than to take a quick look at what this looks like on the server in terms of the actual application code. There's a model behind this, and the model has lots of complexity, especially around this synchronization mechanism that I don't really need to show you, I don't think. But to sort of give you a feeling of what a moderately sized application might do, well, so first thing is we define a check function, and in this case, I decided that the check function would simply call back on the route handler. It might be useful to have a little bit of sugar and bobo to this could be a common pattern, but and then we have a bunch of wrappers of the low-level bobo functions for creating route handlers and supplying the check function as an argument, so we don't have to do that every time. This is an example of something that is a tough abstraction to provide in a library because this represents sort of application policy. You know, if Bobo did this, there would undoubtedly be situations that it would not work for, and then you'd have to sort of fight the framework. But it's really easy to provide this in at the application level, and then you know exactly what it's doing because it's within your application. In our subroute, so in this application is pretty simple. So we have one subroute with a bunch of routes, and the only purpose of the subroute, notice that the route for the subroute is the empty string. So in this case, we're not really splitting up URL processing. We're just sort of combining a bunch of common logic. We're saving the request as an attribute. We're saving the database connection. We're actually doing our check to make sure that we're authenticated. And then we save some convenience. And then we're doing a sort of an authorization check in that, okay, so they might have an authenticated email. We're actually using Mozilla Persona to do the authentication in this case. But it might not be an email that we want to provide access to. So here we do a check right in here. We could have done it in the checker that says, well, if they're not in the user database, then they're not allowed. And then we save the email for later use. Again, the error bit is a bit of sugar for raising a Bobo exception or returning a Bobo exception. This response function takes care of the update mechanism. It calls into the model to get updates. It's not really that important that you pay much attention to that. And then we have the various route handlers. So, for example, here's the poll, and this poll does nothing except that this response function, which knows how to get updates out of the model and look at the generation that was passed in, just basically sends updates. This is a more interesting example where we're getting users, a list of users and a list of admins, and because the data are coming in as JSON, we know that these are already lists. We don't have to sort of, if you're dealing with form data, something that might, you can have a parameter that might be a list or it might be a string, depending on whether there was more than one or not. And so, because we're getting JSON, that makes the logic a lot simpler. And then oh, sorry, I wasn't even looking at you, sorry. And then the last bit that I wanted to mention is we have this route that basically moves some tasks from one state to another. We can actually implement this in terms of one of the other routes. So when it's calling self-update release with some of the data that's passed in, it's actually calling this function down here. So even though this function is a route handler, it can also handle regular Python calls. Okay, well, I think I'll stop there. Almost stop there. Let me put the last slide so you can see where to get more information if you're interested. So these slides are available at this URL up here. I suppose they'll be made available through, well, of course we got the video, so, but they're available at j1m.me/today's date. You can also, the Bobo documentation is available at bobodigicool.com, and there's various other sorts of things. Do we have time for any questions? This crowd doesn't ask many questions, so I don't think it'll take much time. Any questions? Yeah?